Hi everyone. We have a remainder question which says find the remainder when 32 raised to the power 32 raised to the power 32 is divided by 9. Okay, so how do we solve such a question? So let's say I simply write this as 32 to the power x, where x is the power of 32, which is 32 to the power 32. And let's look at how this behaves with respect to divisibility by 9. So let's try and find out 32 to the power x. What remainder would it give when divided by now 9? Now, how can we move from here? One of the ways is to find the closest multiple of 9 to 32, which is what? Which is 36. So, can I write this 32 as 36 minus 4? So, 32 to the power x is basically 36 minus 4 to the power x, and that divided by 9. What should be the remainder, right? Now, if you observe, if I actually expand this entire stuff, right? So if I open up the bracket and entire uh, expression is broken down, right? All the terms except the last term will be a multiple of 36, right? All the terms in this expansion except the last term, which is minus 4 to the power x, will be multiple of 36. And we know that 36 is a multiple of 9, right? Which means all the terms except the last term minus 4 to the power x, right? And all the remaining terms except minus 4 to the power x will clearly be divisible by 9 because they are multiples of 36. And if they are divisible by 9, they will always give remainder 0 with 9, right? So this problem basically boils down to finding remainder when minus 4 to the power x is divided by 9, right? If you look at our original problem, x was nothing but 32 to the power 32. So x is basically even. So minus 4 to the power x by 9 can be said to be same as 4 to the power x. Remember, when 4 to the power x is divided by 9. Why? Because minus 1 to the power x. So minus 4 to the power x is basically minus 1 to the power x multiplied 4 to the power x. Minus 1 to the power even number is going to be 1, right? So I can simply drop this minus sign from here and I can simply say that this is the same as finding remainder when 4 to the power x is divided by 9, right? Okay, now let's look at how do different powers of 4 contribute to different remainders when divided by 9. So let's start with 4 to the power 1 where x is 1. What's the remainder when it is divided by 9? So 4 to the power 1 is 4. So it gives a remainder of 4 with 9 when divided by 9. What about 4 to the power 2? So 4 to the power 2 is 16. So it gives a remainder of 7 with 9. What about 4 to the power 3? 4 to the power 3 is 64. So it gives a remainder of 1 because 63 is a multiple of 9. What about 4 to the power 4? Now 4 to the power 3 has given us a remainder 1. So 4 to the power 4, it means you multiply 4 one more time, will give a remainder of 4 with 9. What about 4 to the power 5? So 4 to the power 5 is basically this 4 multiplied 4 again 16. So which is 7 with 9 again. So what do we observe here? After the first 3 remainders, we see a repeat of remainder, right? So 4 to the power 1 gives 4, 4 to the power 2 gives 7, 4 to the power 3 gives 1, and then that cycle repeats. So then you again have 4, 7, 1, 4, 7, 1, 4, 7, 1 as remainders, which basically means the powers of 4 have a cyclicity of 3 with respect to remainders with 9, okay? What can I generalize from here is that any number of the form 4 to the power 3k plus 1 is going to give me a remainder of when divided by 9 is going to give me a remainder of 4. Okay. Any number of the form 4 to the power 3k plus 2 when divided by 9 is going to give me a remainder of 7, and any number of the form 4 to the power 3k when divided by 9 is going to give me a remainder of 1. That's pretty clear and evident from what we did above. Okay, now remember that any natural number n can be expressed mutually exclusively among one of the following: 3k plus 1, 3k plus 2, or 3k. You can express any natural number as one of these three: 3k or 3k plus 1 or 3k plus 2, right? It has to fall within one of these three categories, which basically means if I use this generalization and come back to the problem at hand, so the problem at hand was 4 to the power x by 9. Now remember, this x is nothing from the original question. This x is nothing but 4 to the power 32. So x is 32 to the power 32. So 4 to the power 32 to the power 32 by 9. Now, given this generalization, if I can express this power 32 to the power 32 in one of these three forms, categories, like 3k plus 1 or 3k plus 2 or 3k, then we will be done, right? Then we know how to go about it. So let's try and express 32 to the power 32 in one of these forms. So basically what we need to do is find out the remainder when 32 to the power 32 is divided by 3. So if you look at 32 to the power 32, can I write, so 32 is at a distance of 1 units from a multiple of 3, which is 33, right? So basically 32 is nothing but 33 minus 1, right? So if you actually expand this, all the terms except the last term, which is minus 1 upon 32, will be, so all the terms except the last term, which is minus 1 to the power 32, will be multiples of 33, right? In this expansion, which means all of them except minus 1 to the power 32 are multiples of 3 and are therefore divisible by 3. So the only term which is not divisible by 3 is this last term, minus 1 to the power 32. Other way of looking at it is 32 is at a distance of minus 1 from 33. So you can directly also write it as minus 1, right? So minus 1 to the power 32 is nothing but 1 itself, right? Minus 1 to the power 32 is nothing but 1 itself. Now, basically what it means is when you divide this expression 32 to the power 32 by 3, you are going to get remainder as 1. That's what it means. So I can write this expression as 3k plus 1. That's it. Now, if you bring this to here and you write this expression as 4 to the power 3k plus 1 by 9. So basically you need to find the remainder when a number of the form 4 to the power 3k plus 1 is divided by 9. If you go to our generalization, the three cases, and find out which case is the one that we are talking about, you will find that this is the case number 1. 4 to the power 3k plus 1 when divided by 9 gives us a remainder of 4. So this expression also will give us a remainder of 4 when divided by 9. So the correct answer to the original question is going to be 4. Thank you.